Let's talk about writing out our trig ratios. So just a reminder, we typically use this device to remember SO, CA, TOA. But what that means is that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So it just goes in order. First letter is the trig function, second letter is the numerator, third letter is the denominator. Okay, so if you were given a triangle that looked like this, let's put these numbers in here. Let's say this is 5, and this is 12, and this is 13, and this is our angle. I'm going to call it theta. Okay, and I said write down all the trig ratios. Well, let's start with sine. The sine of my angle, sine of theta, I'm going to make that a little neater, equals, well, sine, let's do some labeling here. I always label them like this, hypotenuse, because that's the longest side across from the 90-degree angle. Then I do the adjacent, the one that also touches the angle. Should be the two that make up the angle. And this is the opposite. So sine is opposite over hypotenuse. So just put those lengths, 5 over 13. Then the cosine of theta is the adjacent over hypotenuse, and the tangent of theta is equal to opposite over adjacent. And the thing is, anytime you have a similar triangle, you know, it has the same, like if you doubled each of these, let's say it was like 24, 10, and 26, that would mean that this angle must be the same, because you have some kind of multiplier that would transform this triangle into the other. So that's why these trig functions, these identity or these ratios here, will help us to solve for missing angles and sides, because for any similar triangle, they will hold true. Let's do one more. Let's say we had this, and we didn't have the hypotenuse. Well, of course, we can find the hypotenuse using Pythagorean theorem. We can square the two legs and take the square roots, so 16 and 64. So there's the square root of 80, which can be rewritten as 4 square roots of 5. So now from the angle right here that we were given, I like to label the hypotenuse, the adjacent, and the opposite. So the sine of theta is opposite over hypotenuse. Reduce that a little bit. Cosine is adjacent over hypotenuse, which we could reduce even more, or even nicer. And tangent is opposite over adjacent, 2. So remember, you can always use Pythagorean to fill in the missing sides if you need to, and then use those ratios that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Let's do one more. I've given you the hypotenuse and one leg, so of course we should solve for the missing side. We should say, well, 10 squared minus 5 squared equals this side squared, so square root. So 100 minus 25, this is the square root of 75, which we could reduce. The square root of 75 could be written as the square root of 25 times the square root of 3, which is 5 square roots of 3. Okay, so there's your third side. Now, if I'm going to label them, remember I always like to go hypotenuse first, longest side, then do the adjacent, the other one that makes up the angle. So then this is the opposite side. So the sine of my angle is equal to opposite over hypotenuse. You can reduce that, of course, to 1/2. The cosine of my angle is adjacent over hypotenuse, which you could reduce like that. And the tangent, I didn't leave a lot of room for, the tangent is opposite over adjacent, which we could, of course, just simplify to be 1 over the square root of 3. So always make sure you have all three sides, then label them, and then just use your SOHCAHTOA to write down the correct ratios.